Our third day of guided notes, we will look at the absolute value parent and see what effects, what transformations happen with different changes to the equation. So very much like yesterday, the first thing I want you to do is go through these 4 graphs and quickly put your parent functions in, pause the video, get your parent functions in, and then we'll have our discovery time. Okay, so again, like yesterday, we'll go to our Inspire and get our parent graph in broken and start viewing transformations with a fatter graph. So on your Inspire, you want a graphs page or a graph scratch pad. You'll need to Control G to get your entry line back. And remember, the quick way to absolute value is this button next to 9, and in the menu is absolute value. Once you've chosen it once, it stays there as your default until you change it. So there's our absolute value graph. If you Control G, you get your entry line back. And from here, you can arrow up and change the attributes. Control menu, go to attributes, make it thin and either dashed or dotted. And once you've done that once, you don't have to do that again. Okay, number 1 asks us to see what happens when I add 8 to the end of my absolute value. So in my second graph, I'm going to take my absolute value graph, absolute value of x, and then add 8 to the end. Now, I cannot see my graph because of the window. This stops at 6.67. So there is a graph. You just need to move this down a little bit. But one of the quickest ways to do that is get your cursor active in a white space and Control click to hold. And you can drag your paper down until you can see your graph. Go back to Control G, up arrow to get to that absolute value of x plus 8, Control menu, choose attributes, and make that graph. Okay. And now you can see. So absolute value of x plus 8 translates the graph up 8 units. My new anchor point is 0, 8. Go to your paper and copy that down. Point moved up to 0, 8, and my graph has the same shape from there. So you'll see sometimes on your graph you don't see much at all, and that's okay. The point is to understand the transformations that are happening based on the equation. So we had a translation up 8 units. Alright, so now let's look at number 2. For number 2, we're going to graph the absolute value of x minus 6, all underneath the absolute value, inside the absolute value symbols. So again, go to your Inspire, the function itself. Everything will stay broken and thin as necessary, or thick. So here I need my absolute value, and x minus 6 stays in the absolute value bars. And there's my child graph. So for this graph, my child moved to the right 6 units. Go back to your graph paper, 6, 0. And from there, my graph stays the same size and shape. So that transformation is a translation to the right 6 units. Number 3, we're going to see what effects that negative has on my absolute value parent graph. On your Inspire, and we're going to graph negative absolute value of x. Now, again, I moved my graph earlier. Probably to get back to a standard viewing window, you could menu, window zoom, and number 5 is standard. That'll get you back there for all of your graphs. And you can clearly see now that that is a reflection over the x-axis. So go back to your paper, and all the points on my parent get reflected and go the same distance away from the x-axis as the parent is. And our last graph for tonight is 2 times the absolute value of x. Go to your Inspire, File, and arrow over and change that negative to a 2. And there is my child graph. I have a dilation. And here, again, with dilations, often you'll want to look at the table of values. This one's different from earlier dilations. Here my points have vertically stretched away from the x-axis. So before, when I got a wider graph, that was a vertical shrink back toward the x-axis. Here I have a skinnier child graph, which makes it a vertical stretch away from the x-axis. And those points will be twice the distance. If you're curious, do your Control-T for table, and look at your points for your double absolute value graphs. What was 1, 1 becomes 1, 2. What was 2, 2 becomes 2, 4. So these distances from the x-axis have doubled. Go to your paper, and this distance was 1 away from the x-axis. That vertically stretches to twice away. So 1, 1 becomes 1, 2. 2, 2 becomes 2, 4. 3, 3 becomes 3, 6. 4, 4 becomes 4, 8. 5, 5, 5, 10. And same on the other side. So that transformation is a dilation, and it is a vertical stretch. My parent point stretched twice the distance away from the x-axis. That's it. Have a great night.